So here's another mechanism for a virtual parabola. And again, so here we have it on this page. And again, it's driven by a gear pair, which keeps a couple of angles the same, while we're going in the opposite directions. So let me share my screen and we'll get to work on this virtual parabola mechanism. Here we are with GXWeb. We're going to put one of the gear pair here. Actually, first of all, I'm going to draw the line that joins the center of the two gear pairs. This is going to be a parameterized mechanism. There'll be a whole range of possibilities, and it'll be parameterized by the angle here, which I'll call alpha. And so my first gear in my pair is going to be here, and the next one is going to be here. And we'll make both the same radius r. So everything is going to be related, all the distances are going to be related to r in this model. Now, what we have is one fixed link coming off of this link, of this gear wheel, and it's attached firmly to the gear wheel. So as the gear rotates, so does this. And we define that by, we'll specify that angle to be theta. So as the gear rotates, this line rotates, and this line is a fixed length, and the fixed length is twice the radius. Okay, now we have another little structure here. We have another link of fixed length. 2r comes off of here, and it comes with a slider attached to the slider here, so that this length BE can change. But this angle here is going to be theta also, and it's driven by the gear pair. And we're then going to, let's just change theta a bit so we move it. We can move it a little bit away from where we were there. Okay, we'll have it up here. We're now going to add a pair of links like this. This one stays perpendicular to this one. And this one stays perpendicular to the y-axis. It's all arranged with clever little mechanisms. But now, having done this, f is the point that I take the locus of as theta varies. And that gives me my model, although that is not what I was expecting. Here's what's wrong. I did not specify this length. So I've, sorry, the length AE needs to be constrained. It's supposed to be 2r. And now that is what I was expecting. As you see, theta can vary here, but it's going to go degenerate in the bottom half. So we really want to only focus on the top half of the mechanism. So let's make it go from minus 1.57 to plus 1.57. And there we get the top half of the mechanism. We can top half of the curve rather, and we can find out what the curve is. Let's have a look at this equation. there's this fourth order equation. You see, we've got this sine alpha and cos alpha, so it depends on our parameter alpha, the particular shape of the curve. And so by changing alpha, we can have different shapes to that curve. And of course, we can animate over theta.